In this video, they're asking us to solve these radical equations for real solutions. The first thing we would normally do is to perform the steps that are listed here in green, and that would mean we should isolate the radical, raise both sides to the needed power, repeat the steps until all the radicals are gone, and then finally solve and check. However, for example A, we don't need to do any of that. And the reason why is that this is a square root. A square root can never produce a negative result on the other side. So if we're looking for real solutions, there are no real solutions for example A. So our answer will be no real solutions, because there's no real number that you can take the square root of and end up with -9. Okay, very good. So for A, that's easily done. Let's look at part B. For question B, it looks like we have a third root, and what we're going to do to solve that is to isolate the radical. It'll be 5 minus 2x, and we're going to move the 2 over to the other side, giving you equals to 2 on the other side. And then we have to raise this left-hand side to the third power, because that will cancel out the third root. And we'll do the same thing to the other side. It'll end up giving us 5 minus 2x is equal to 8. Now, at this point, we simply have a linear equation which we can solve very easily. We'll subtract 5 from both sides, and that'll end up giving us -2x is equal to just 3. And then we divide both sides by -2, giving us that x is equal to 3 over -2. Or in other words, x is equal to -3/2. Now we should always check our answers. This is especially true if we have a radical with an even index. So something with a third root, we're probably okay, but we should still check to make sure. Let's go ahead and plug in our answers and see what happens. So if we have 5 minus 2 times -3/2, does that indeed give you +2? Well, the 2 here will cancel with the 2 there, and we'll have -3. So that's going to give you the third root of 5 plus 3 is equal to 2. And that is correct. It'll be the third root of 8, which is equal to 2. So that checks out. So this is a valid solution. The reason why we need to always check these solutions is that when you raise an equation on both sides to a power, you have the possibility of introducing extraneous solutions. When you raise an equation to the nth power on both sides, you will get sometimes extra solutions that don't actually work in the original equation. So we're forced to check. That's the point. So always make sure you check your solutions. In this case, our solution works just fine. All right, let's move on to example C then. So for example C, we can simply square both sides of the equation to remove the radical. So I'll square the left-hand side. I'll end up with x squared is equal to, and then we'll square the 4 square roots of x. So when I do that, I end up with x squared is equal to 16 times x, right? Because you squared the square root of x, you just get x. Then from there, we can basically bring the 16x over to the left, giving you -16x is equal to 0. And then once we have that, we can factor out the common factor of x. X goes into x squared, leaving you just x. It goes into -16x, leaving just 16, and that will be equal to 0. Then we apply the zero factor property, which says, hey, two things are multiplied here, the result is 0, so it must mean that either the first one is 0 or the second one is 0. And then we already have the solution here, x equals 0, and then for this one, it'll be that x is equal to just 16. So there's our two solutions. So again, whenever you square both sides of the equation, you might introduce answers that don't actually work in the original equation. So let's go ahead and check our answer to see if it actually works. We're going to plug 0 into both sides. We'll get 0 is equal to 4 times the square root of 0. That is indeed a valid solution. And then if we try plugging 16, we'll have 16 is equal to 4 times the square root of 16. Well, that's 16 is equal to 4 times the square root of 16, which is 4. So 16 equals 4 times 4 is also a valid statement. So this means both of our solutions check out. So they're both answers to the equation.